Hi, this is Ms. Billerbeck, and we're going to talk about section 14.2, map scale and calculation of area. So on a map scale is the ratio of a distance on a map, the paper part of a map, to the corresponding actual horizontal distance on the ground. So what we see frequently on maps are bar scales or a linear scale. So it looks something like this, where this would be 5 miles in that direction, 0 miles, 5 miles, and 10 miles. Okay, and it just helps us to see how we would represent, say, an inch to 5 miles. Okay. So a ratio or representative fraction, abbreviated as RF, indicates how many units on the Earth's surface is equal to 1 unit on the map. All right, so let's take a look at some common map scales. So these are common map scales used in the US. So 1 to 24,000 is 1 inch to 2,000 feet. And 1 to 63,360 is 1 inch to 1 mile. So this one's very, very useful. And then 1 to 316,800 is 1 inch to 5 miles. This one also is very, very useful. If we're using old-fashioned maps that are in miles, which is typically what we use in the US. So then we have 1 to 50,000, which is 1 centimeter to 0.5 kilometers. This would be more of a European thing that people would need because we don't use kilometers on our maps very much. And 1 to 1 million would be 1 centimeter to 10 kilometers. Okay, so I thought, well, you guys may not know what maps look like because you use Google Maps. So I got a map that I'm pretty sure some of you have seen. Okay, this is a ski resort map. Okay, this one happens to be Kirkwood. Okay, so as you can see, it represents the mountain village, and you've got your ski runs and all the chutes here. Oh, I really miss skiing. Okay, so this one I looked and I looked and I looked and I saw no little the bar scale or linear scale. So there was nothing, just a bunch of places to eat. Okay. So they just cut it to what are my clients actually going to care about? Okay, they don't care about how many miles am I skiing down the wall. So, you know, when we're skiing, we don't really care about how far we're going. We're just enjoying the mountains. Okay. And then I checked out Heavenly just to see, is this normal not to have a bar chart? So I was looking at all the ski resort mountains, and nope. They give you some things like this where they say, oh, 7,480 feet is the same thing as 2,280 meters. And that's kind of cool. You know, it gives you a little conversion here. 10,040 feet is the same thing as 3,060 meters. Now, I kind of like that, but still, no bar scale. Okay, or linear scale. So, then I got the mouse out that I use, Yosemite. Okay. So these are important. So I looked. This is Yosemite National Park, and there it is, the bar scale. Okay, so it does start at 0 and it goes to 5 miles because that's important. I don't know what the other 5 miles was back on the other side, but your book seemed to think that was important. So how I use this in my old-fashioned ways is I'm like, okay, that's 5 miles. What? Okay, here's the trail. Okay, so if I go here, then here, then here, that's 15 miles to Rock Camp. A little more than 15 miles. It's kind of switching back a lot, so it could be kind of rugged 15 miles. And, but we'll see. That's a possibility. I could do that in a day. But it definitely wouldn't be a return. I'd have to be camping out there. And then I looked at Mount Rainier. Does that one have a bar graph? And it does. Look at that. And it even tells you what direction is north. So, it says kilometers because so many people are from other countries. Yeah. So then this one's 2 miles. So I see, there's a Pacific Crest Trail. That's one set of 2 miles. Ooh, that's a bad switchback. That's a bad 2 miles right there. Look at all those switchbacks. Whew, very bad. Okay, so that's 4 miles, but it's looking pretty rugged. So that's how I would look at this map. Okay, and yet I have another map. Mount St. Helens. Woohoo! Finally made it there last summer. And look at these bar charts. Look at that. They have kilometers and miles. This is very international, Mount St. Helens. So it is definitely a destination. I hope you all can make it there someday. Very spectacular. So anyway, this goes back to 5 miles. So you just kind of go, that's 5 miles. And then, there's a trail right there. So it's about 5 miles there, 5 miles there. So that looks like about a 10-mile loop right there. So this is about a 10-mile loop. So these bar scales are very important when you're out there hiking because you just kind of estimate that's 5 miles, and you figure out what 5 miles is on the map. And they're very light. And sometimes we don't have cell reception, so we aren't able to use our phones. Believe it or not, we are totally unconnected sometimes. So paper is a very lightweight way to figure out where you are. So now let's look at how we calculate using maps. So we have a distance of 4 inches on a map, and it represents the actual distance of 5 miles. So find the map scale 1 to R. Okay, so first of all, we have 4 inches, the distance of 4 inches on the map. So that's the paper. Okay, so I am gonna write 4 inches, and that represents a distance of 5 miles. So this is going to take us a little time to figure out what our reference is. So first we have 5,280 feet in 1 mile. And then we have 12 inches and 1 foot. So we're going to be multiplying 4 inches, and 5 times 12 is 60. So we're going to put that in there. And the miles cancel, the feet cancel, so we just have inches. So it's 60 times 5,280 inches. Okay, so this is much easier to multiply. That's why I did 5 times 12 first. So we can just multiply by 6 here. So let's put 4 inches. Then 6 times 0 is 0. 6 times 8 is 48. Carry a 4. 6 times 2 is 12. Plus 4 is 16. 6 times 5 is 3. Plus 1 is 31, and then there was an extra 0. So that's how much 5 miles is in inches. Okay, so that's why this is a better unit of measure than this, because this is hard for our brains to comprehend, but that is not. Okay, so this is not a 1, so that's a problem. So, as you know, we divide by 4 because we need a 1 right there. And we'll divide by 4 inches to get this unitless. So we have 1, and then 31 divided by 4. Let's do this here. So since this is a very long number, so 4 into that is 7. So we have 28. Subtract, we get 3. And then there's 9 in here. And drop an 8 down. So there's 2 in the 8. And then we have another 0 and another 0. So this is what the conversion ends up being. Okay, and we have to keep in mind that this was inches that we were doing. So that's really important that when you get this conversion, remember which one it is, inches. Because when you get to the next parts, that's when you kind of need to remember what this map scale conversion is. So this map scale, we would write it as 1 over 79,200. So that's our map scale in inches. Okay, so then it says, if I have 2 cafes and they're 6 inches apart. Okay, so I have 2 cafes 6 inches apart on the paper map. Okay, so I know that my map scale is in inches. So it says, well, how far apart are they in miles? Okay, so if I want to do this the easy way, well, the easy way would be go back to 4 inches equals 5 miles and make this more of like this. Actually, let's put miles on top. Okay, let's go back to this ratio, get comfy with it. This is the ratio we started. And now let's do a proportion. So 5 miles is the same as 4 inches. So we're going to put 5 miles over 4 inches. And that's going to equal, we have the cafes are 6 inches apart, but we don't know how many miles. So that's how we're going to figure it out really fast. So to get this 6 out of there, we're going to multiply by 6. And we might as well multiply by 6 inches. So we cancel some units out. So that cancels there, that cancels there. The inches cancel there and there. So we get x equals, and 5 times 6 is 30 miles over 4. And when we divide that, we get 7.5 miles. Okay, so once we keep track of finding the units that are easy, because we really don't want to do a lot of work in math, we want to make it easy on ourselves. Okay, so that's why I started back with this and not the map scale. All right, so it says if 2 supermarkets are 6 miles apart, how far apart are they on the map? Okay, so we have 6 miles apart. So if we go back to this original ratio, and we say, well, we're going to find centimeters now. So we want the centimeters on top. So let's put 4 inches here. and 5 miles down here, and that's equal to 1. And then we have the supermarkets are actually 6 miles apart. So how far apart are they on the map? So we're going to put a Y there for the supermarkets. So we have 6 miles right here. And that cancels, and the miles cancel, and we get 24 over 5, and we're in inches, equals Y. So Y is going to be, there are 4 5s and 20 with 4/5, so we could say 4/5 inches, or that's 4.8 inches. So there you go. That's how we figure out how far the supermarkets are apart on the map. Okay, so let's go to example 2. Okay, example 2, we have a scale of a map is 1 to 40,000. A rectangular field is 3 by 6 centimeters on the map. All right, so what we're going to do is first, it says find the actual area in kilometers squared. So we start with 3 centimeters by 2 centimeters, and that's going to equal 6 centimeters squared. So our scale is 1 centimeter equals 40,000, and that's centimeters. And then we're going to convert that to kilometers. So we're going to put 1 kilometer is the same thing as 100,000 centimeters. So we have 1 centimeter equals 0.4 kilometers. Okay, because 40,000 divided by 100,000 ends up 4/10, and 4/10 is 0.4. So that's where I got 0.4. Now, if we do 1 centimeter squared, that means we're going to do 0.4 squared, which is 0.4 kilometers squared. So we have 1 centimeter squared equals 0.16 kilometers squared. And now we can find A. So we can take the 6 centimeters squared, and we're going to multiply by the ratio of 0.16 kilometers squared over 1 centimeter squared. Because see, we have that right here. They're equal. So this is a big 1 right here. This is the same thing as 1 centimeter squared. So when we figure that one out, it ends up 0.96 kilometers squared. Okay, because 6 times this is 0.96. Okay, so the next question says, if the actual area that is covered with a brush is 2 kilometers squared, find the area on the map. Okay, so again, we use this kind of proportion. So we have 2 kilometers squared, but now we're trying to get it converted to centimeters squared. So we put the centimeters on the top instead of the bottom, and we put the kilometers squared on the bottom, because that cancels the kilometers squared out. We're in centimeters squared. Just like the centimeters squared were canceled out up here, and we came out with kilometers. Okay, so when all the magic is done, we end up getting 12 12.5 centimeters squared. So 2 kilometers squared in the real world is represented on the map by 12.5 centimeters squared. So that's what that was about. Okay, so that should do it for maps. So just try your best with this. It's a little bit tough, but if you keep your units with your numbers and follow the units, it's much easier to figure out how to set up the problem. Okay, so keep the units with the numbers, then you can figure out how to do these proportions. Okay, all right, have an amazing JAA day.